Hello and welcome to Ratio Lesson 5. And the aim of today's ratio lesson is to learn what a scale factor is. If you see the two squares that I've drawn there, one of them has each side length 2 centimetres. And if I enlarge it by a scale factor of 2, then each length will be 4 centimetres. So a scale factor of 2 means that I've doubled each side. Here's another example of where I've used a scale factor of 2. I've doubled my first side of my triangle from 3 to 6, my second side from 4 to 8. So my third side I know is also going to double to be 10 units. The angles will all stay the same. So my 90-degree angle will remain a right angle, and each of the other two angles will remain the same size. So if this one here was approximately 40 degrees, this one will also have been 40 degrees. Now have a go at doing this. On some squared paper, if you've got some, draw a rectangle that is 1 centimetre by 4 centimetres, and a square that is 3 centimetres by 3 centimetres, and a triangle that's 4 centimetres and 6 centimetres with a right angle, and then enlarge them on your squared paper by a scale factor of 2. Pause the video and have a go. And these should be the dimensions that you now get, shown in blue. I've not drawn them to scale, and often in maths questions they won't be drawn to scale. Now try drawing these shapes on some squared paper and see if you can enlarge them so they're twice as big and 3 times as big. So you'll enlarge them by a scale factor of 2 and then again by 3. And the answers are written in the different coloured pens now. So making your shapes twice the size, your dimensions should be the ones in blue, and 3 times the size, so a scale factor of 3, will be the answers written in green. And you'll notice that the area that they cover is quite considerably bigger. On these shapes I've made a deliberate mistake, where I've attempted to increase by a scale factor of 2. But you can see that the shapes don't look the same anymore. The blue one looks much longer and thinner, and that's because I've only enlarged the width, the 5 centimetres, by a scale factor of 2 to make 10, and I haven't done the height. So when you enlarge, which means make bigger, a shape by a scale factor, you have to do every length. Here's something for you to try. If you draw an oblong that is 3 centimetres by 4 centimetres and then enlarge it by a scale factor of 2, in other words double all the sides, Then compare your perimeter, area and angles of the two oblongs and make a note of what you notice. You should notice that the perimeter has doubled. So the perimeter of the first shape was 14 centimetres, P equals 14. And in the second shape that you've enlarged by a scale factor of 2 is 28. 28 is double 14. However, when you do the area, which you work out by multiplying, if you remember, 3 times 4, that's 12 centimetres for your first shape. But when you multiply 6 times 8, that's 48 centimetres squared for the second shape. So actually that's 4 times as much. So even though your scale factor is 2, your area has actually multiplied by 4. The angles will have stayed the same. Here's another question for you. There are two triangles. They're not drawn to scale, and you're told that the base, the bottom line of the green triangle, is 5 centimetres. And you're also told that the green triangle is 3 times larger than the pink triangle. Can you find both perimeters? And here's an answer for you. So you know that the base of the green triangle was 5 centimetres. It's equilateral triangle, so each side is also going to be 5 centimetres. 5 plus 5 plus 5 is 15 centimetres, so that's the perimeter of the green triangle. And the pink one is smaller. It's a third of the size. The green one is 3 times larger. So if you divide the perimeter of the green one by 3, that gives you 5 centimetres. So the perimeter of the pink one is 5 centimetres. And here's the final question for you. Jack says that the purple triangle is an enlargement of the red triangle. It's enlarged, made bigger by a scale factor of 3. You can see the units that have been given to you. Do you agree with Jack, and why? If you look closely at the numbers, you'll see that Jack has done something wrong here. He's forgotten to multiply and he's added. So he's done 3 plus 3 to give 6, 4 plus 3 to give 7, and 5 plus 3 to give 8. So he's wrong. So from this video, you should have learned what a scale factor is and what an enlargement means. The scale factor is how much you multiply all the sides of a shape by. And you must multiply them all by the same amount for it to be a scale factor enlargement. And all the angles must stay the same. Thank you for watching. Look out for the next one. Hope you're well. Bye.